Today we'll be exploring functions in the real world. In this video, we'll look at the movement of a swing on a playground. What's so special about it? Let's play the video and see what we notice. So we can see that the swing moves back and forth and takes roughly the same amount of time to do so each time. We can also see that the swing rises and falls to the same height above the ground each time. Pretty cool, right? So now, do you think that we could create a function for the movement of this swing and maybe make a prediction about the number of complete swings we can make? Yes, we can. A swing moving back and forth is what we call a sinusoidal function, or a function centered around sine and cosine. This function has a constant height and constant time periods, which is what we talked about earlier. Let's play the video again to get exact measurements. So we see that the swing at its highest point is 3.5 feet, while the swing at its lowest point, or the center, is 2 feet. It takes 1.35 seconds for the swing to move forward. Believe it or not, we only need these three measurements to create our function, and we can put those into a table. This table should have one column for the time in seconds and one column for the height in feet. At 0 seconds, the swing is 3.5 feet above the ground. At 0.67 seconds, the swing is 2 feet above the ground. And finally, at 1.35 seconds, the swing is at 3.5 feet above the ground again. So using these measurements, let's create our function. If we place the numbers from the table on a graph and take into account parts of this special function, we get the function y equals 0.75 cosine 4.65x plus 2.75. So I know this may sound really complicated, but really what we've done is just plugged in the heights that we already know, along with the time it takes for the swing to move forward, and we've made it into a super compact function, which we can use to make predictions. Speaking of, let's see if we can make a prediction. From our measurements, we know it takes 1.35 seconds for the swing to move from the back to front. Suppose you've been on a swing for 14 seconds. How many of those back to front motions have you completed? Let us know in the comments below. It's not just a swing set we can see this. We can find sinusoidal functions on anything that moves back and forth, like a pendulum, a metronome, or many other things in your house. We can even find these types of functions in the real world, like on the pendulum of the world's tallest grandfather clock in Wisconsin. Wherever you find these cool functions, don't forget to share it with us.